Welcome to Eternal Easy Education. In this session, you are going to learn Chapter 6, Specification and Abstraction. Content of this video is: what is algorithm? What is algorithmic problems? What are the building blocks of algorithm? What is an algorithm? An algorithm is a step-by-step sequence of statements to solve a problem. So, what is the problem? Problem means a question. For example, how to reach the bus stand? It's a question. So it's the problem now. So we have to find the solution to reach the bus stand. Likewise, all the questions can be treated as a problem, and the solution given by us or someone else is said to be a solution steps. The process which are involved to solve a particular question is said to be an algorithm. For example, take that you want to prepare a tea. How to prepare a tea? That is the problem or that is the question. Then what is the result or how to achieve the result? Then there will be some sequence of steps to reach the solution. That sequence of steps can be treated as algorithm. As an algorithm is executed, a process evolves which solves the problem. Yes, if the problem or the question is how to prepare a tea, then there will be an answer as a steps. Take a milk, take the vessel and the next step. So there will be, but the answer will be of different. That means it is not of one solution. The problem may have any number of solutions. So first, what is the problem or what is the question? Then the steps involved to solve a particular problem or a question, the steps are said to be the algorithm. If you ask the question that a problem is having only one solution, means no, a problem can have any number of solutions. So among the set of solutions, we will select the optimistic or a perfect solution from the steps. So an algorithm is simply a step-by-step sequence of statements to solve a problem. We can compare an algorithm to a recipe and the resulting process to cooking. That means how to prepare a biryani. So everyone will be very excited to learn how to prepare a biryani. So the steps involved in that process is said to be the algorithm. Algorithmic problems. Algorithmic problem solving involves construction of algorithms as well as proving properties of algorithm. That means it is the next level, how to take an algorithm as a solution or how to write a proper algorithm for a particular problem. So this is our unit. It means unit 2 and chapter is 6, Specification and Abstraction. So before knowing about the specification and abstraction, we must understand the concept of algorithmic problem solving. So one of the problem solving technique is the specification and abstraction. So an algorithm is a sequence of instructions to accomplish a task or solve a problem. So this is a statement for what is algorithm. There are many definitions for algorithm, and also it's a 2-mark question. What is an algorithm? An instruction describes an action. Instruction describes an action or an event. When the instructions are executed, a process evolves. That means if 2 to 3 steps, that steps is said to be the instruction. So if we execute 4 instruction or 5 instruction, a particular process is accomplished. Here also there is a definition. An algorithm is a step-by-step sequence of statements intended to solve a problem. When executed with input data, it generates a computational process and ends with the output data, satisfying the specified relationship between the input and output. So this definition is required as a computer science student. Basically, an algorithm is a common topic for all the problems. But being a computer science student, we must know some of the technical terms which is related with our field. Here, the algorithm is going to be written for a problem which is going to be solved by the computer. So, as a computer science students, we are going to write the algorithm which is going to be executed by a computer. So, the computer is going to execute a program, that is a programming language. So, this programming language in the sense, language means it's the communication tool between the persons. Am I right? So, Tamil is a language, English is a language, as well as French is also a language. Why we are learning Tamil, English, French means it is the communication tool for us. Okay, right? So this communication tool, this particular Tamil language or English language is to communicate the information between the humans. Here, the programming language is to communicate with the computer. So now, as a computer science students, we are entering into the level that you are going to communicate with the computer, or you can feel proud that you are going to instruct the computer to do a task. So to instruct the computer, you should learn the language which is required to communicate with the computer. There are many programming languages. Among the programming languages, in your syllabus, you are going to learn C++ in 11th standard. So before writing a program for a particular problem, you must know some of the things. So before writing a program, you must know the basic things which are said to be algorithm and flowchart. So the flowchart is a pictorial representation of a process. An algorithm is a statement which is going to be written in English. So first you should prepare yourself for the solution for a particular problem or a question. So the solution should be written in statement, then it is converted into diagrammatic representation, then it is applied to a programming language. Once the algorithm is pakka, that means the steps to solve a problem is optimistic or a perfect thing, then that particular algorithm can be applied to C, C++, Java, any programming language. So the basic thing is algorithm. So algorithm means finding a solution for a problem. Here the problem is just a question for you. So if there is a question, then there is an answer. So you are going to find out the answer, and the answer here, it should be going to be written in statements, and there must be some format to write the statements. Then following the format, you will find out the solution. Is it clear, children? So this is very important to know about algorithm. Why algorithm is there? Algorithm is a step-by-step process to solve a problem. Then why you are learning algorithm means, because you are going to be a programmer. So before writing a program, I must know the solution in steps. That is the proper methodology. Then if the solution in algorithm format is pakka, it can be applied to any programming language. So those who are having an aspiration to become a computer science engineer, that means on the basis of if you want to be a programmer, then you must concentrate on algorithm, because if you know to write algorithm, then you are going to be the best person of a programming, because the C and C++ or the Java or VB, it may change, but algorithm never changes. So if you find a pakka algorithm, this algorithm can be applied to any one of the programming language. Is it clear, children? So algorithm is nothing but a step-by-step process to solve a problem. As a computer science student, your problem is going to be a question. Then you are going to find the answer for that. A computer, and we are interested in executing an algorithm in a computer can only execute instruction in programming language. The instructions of a computer are also known as statements. Therefore, ultimately, algorithms must be expressed using statements of a programming language. So simply they want to say that write the algorithm with the terms of programming language that you will learn little by little. So first thing, what is algorithm? Next, there is an example like add two numbers. To add two numbers, we proceed by adding the rightmost digit of two numbers, then the next rightmost digit. That means they are saying the steps. See here, there is a number 2586, then 9237. Here is the number 2586 and 9237. So the process must start from rightmost. So 6 plus 7, 13. So 3 and the balance is 1. Here this is said to be steps. Okay children, don't confuse this number with the adding numbers. So it is step. So first step is from the rightmost. So 6 plus 7, 13. So 13 is here, 3 is here, 1 is carryover. So 18 plus 3 plus 1, it is 12. So 2 balance is 1. So 2 plus 5 plus 1, 8. Again 2 plus 9, 11. 1. And the carryover is here is 1. This is not number. This is number 1 and number 2. Is it clear children? Don't confuse with this 1 and 2. It's actually this 1 should be here. The number 1 and number 2. Okay. So the net result is 11823. So this process is said to be algorithm. That means finding the solution, and this step is going to be the optimistic. Optimistic means adding of two numbers is proceed only based on this. There is no other procedure for adding two numbers like. Then algorithmic problem. There are some principles and techniques for constructing algorithms. We usually say that a problem is algorithmic in nature when its solution involves the construction of an algorithm. That means if a question is having a solution with the proper steps, then it is said to be algorithmic in nature. Some types of problems can be immediately recognized as algorithm. Consider that they are given two examples. One is goat, grass and wolf. I hope you remember the problem because you might learnt or you might heard in your lower class. The problem is in left side there is a goat, grass and a wolf. We have to think that it is in the bank of a river. I have to take all the three to the next or opposite bank of the river. So if it is so, if I take the grass and the goat together, the goat will eat the grass. If I take the goat and the wolf in the same place, the wolf will try to eat the goat. So there is a procedure to take everyone to the next side, and there is a step. So this steps to take all the three there involves 9 to 8 steps. Each time 2 person will be in the boat. Like that, there is some conditions to take the three thing to the opposite side. So that particular algorithm or particular steps is said to be the algorithmic solution. A farmer wishes to take a goat, a grass bundle and a wolf across a river. However, his boat can take only one of them at a time. The first criteria is one is at a time. So several steps are necessary to cross the river. Moreover, the goat should not be left alone with the grass. Otherwise, the goat would eat the grass. And the wolf should not be left alone with the goat. So the first criteria is one at a time. Next, the goat should not be alone with the grass. At the same time, the wolf should not be alone with the goat. So how can the farmer achieve the task? That is the question. Initially, we assume that all the 4 are at the same side of the river. That means 4 in the sense goat, grass, wolf and the farmer. all the 4 should be in the opposite side. Yes, that is our requirement. The former must be in the boat when crossing the river. So every time the former is in the boat. The solution consists of sequence of instructions indicating to or what should cross. Therefore, this is an algorithmic problem. Instructions may like let the farmer cross with the wolf or let the farmer cross alone. So, we can have many number of steps to achieve the required result. However, some algorithmic problems do not require us to construct algorithms. Instead, an algorithm is provided and we are required to prove some of its properties. That means they will give a solution with the question and the answer. Then we will decide the properties. Properties means conditions should be there to achieve a particular result. Here there is another problem called chameleons on Chromeland. Chameleons on the Chromeland means on the island of the Chromeland there are 3 different types. How many different types? 3. One is red, and another one is green, and another one is blue. There are 3 types of chameleons. Whenever 2 chameleons of different color meet, they both change color to the third. For example, if a red and blue meets, the red and blue has to convert to the third color of green. For which number of red and green and blue chameleons it is possible to arrange a series of meeting that results in all the chameleons displaying the same color. So, the question is, there are 3 chameleons and the answer is, if 2 different chameleons meet, the 2 different chameleons will change to the color of the third. Likewise, at the end, all the chameleons will be in the same color. We want that result, but we must know the number of possibilities or how many numbers would be the red, green, blue, because there is a condition to have red and blue and green in a particular preposition to achieve this result. This is an algorithm problem because there is an algorithm to arrange meetings between chameleons. Using some properties of the algorithm, we can find out for which initial number of chameleons the goal is possible. Because if the initial number is changed, the goal never be achieved. See here, chameleons of Chromeland problem. So construct an algorithm that arranges meeting between 2 different types of chameleons so that they change their color to the third type. Can see a blue, yellow and red. There are many number of chameleons of 3 colors. First one. Then the second point is, if 2 different chameleons meet, like the blue and yellow, then it has to change to the third one, pink. Understood, children? The both are 2 different colors, but they meet, they have to convert to the third different color. So at the end, all should be in the same color. This is our requirement. So how to achieve this? For that, we must know what is the initial number of chameleons for all the 3 colors. So to achieve this, only application condition is any 2 color chameleons must be in same counting. I'll repeat, any 2 chameleons must be in same counting. Let us represent the number of chameleons of each type by the variable A, B and C. For example, capital letter A, that is for small letter A. Let A equal to B be the input property. That means any 2 color must be in same number. The input and output relationship is A equal to B equal to 0 and C equal to A plus B plus C. Do you understand? That means if A is equal to the number of B, then at the end, counting of A and B and C is equal to C. That means the third color. let us name the algorithm monochromatize. Here the algorithm name is monochromatize A, B, C. Input is A equal to capital letter A. That means the A represents the total number of chameleons of first type A. Then B represents the total number of chameleons of type B. Next color. Then C is for third color. The condition is A equal to B. That is, two colors must be in same number. Then the expected output is A equal to B equal to Z. That means at the final, the two colors which are in same must be in 0, and the third color will become the total number of chameleons. So the condition is A equal to 1, that means A minus 1, B minus 1, then C equal to 2. That means one blue color is reduced, one yellow color is reduced, then pink color will become 2. That means addition of 2. Listen carefully. Any two colors must be in same counting. At the end, the third color will be the sum of all the three colors, and the two colors which are in same number will be of 0. I'll explain in detail. Actually, this video is mine. This explanation is for your 12th standard first chapter. Actually, your 12th standard first chapter is having a link with your chapter 6, 7 and 8. Okay, consider. Now, take the color of chameleon yellow. A is in 3 and the color of B also in 3. So, A and B are in same number, 3 plus 3 and 3. Okay, the third chameleon is in the number of 4. So in the first meeting, one yellow is meeting another one blue. Then the both are changed to pink. So in the first step, color yellow is reduced with 1 and color B also reduced in number 1, and the color pink is adding 2 numbers because here 1 and here 1 is added to the pink color. Likewise, in the next meeting, one color is reduced in yellow, one color is reduced in blue, but the two colors are added to the next number of pink. So it is 8. In the next meeting, one is taken from yellow and one is taken from blue, and the 1 plus 1 is given to the pink. So here the net result is achieved. What is the result? 0, 0. So at the final, the two chameleons which are in same number, A and B, become 0, and the third number has become the total number of A plus B plus C. Yes, 3 plus 3 plus 4. So it is 10. So we achieved, right? I hope you have learned what is algorithm and how to achieve a condition for a required output. Okay, children? So, you have seen an example for this, but now you are going to learn how to write. So, how to write means you must know the building blocks of algorithm. So, to write the steps, we must know what is the data and what is the variable. What is the meaning of control flow and what is a function? First of all, what is the data? Algorithms take input data, process the data and produce output data. I'll repeat, algorithm take input data, process the data and produce output data. So computers provide instruction to perform operations on data. Data means the information given or the type of the information. For example, if it is sum of two numbers, input is 2 number, process is addition. Output is one number, that is the addition of two numbers. So the data is the content given to the algorithm to do the process. For example, there are instructions for doing arithmetic operations on numbers such as add, subtract, multiply and divide. There are different kinds of data such as numbers and text. So adding of numbers means the data type is number. If you add two words like good plus morning, it's said to be good morning, then it is text. So in programming you are going to do many things. Then what is a variable? Variables are named boxes for storing data. So we cannot use a data without a variable in programming language. When we do operations on data, we need to store the results in variables. That means here the variable is like our memory. For example, if I ask you to sum, say the summation of 100 plus 200, the input data given to you is the 100 and 200. So both are numbers. So you will store the 100 and 200 in your memory and do the multiplication in your brain itself, and you will store the answer 300 in your memory. Then if I ask you to say the answer, you will say the answer through your mouth, right? So the variable is the place where the data is stored. That is like our memory in our brain. Computer is having a storage place to store the data. So that is said to be the variable. So the variable concept is very important. You must be crossing the variable name throughout your programming life if you are going to be a computer science student. So in the building blocks, you have learned what is data and what is variable. Then you must know what is control flow and function. So I know data, that is the thing which the algorithm is going to be written. Variable, that is the place where data is stored. Then what is control flow? Control flow means algorithm is a sequence of statements. However, after executing a statement, the next statement to be executed need not to be the next statement in the algorithm. For example, if you think that you are writing the solution one by one, it is not mandatory to write the steps one by one continuously in a sequence. There will be some changes in executing the statements. So the changes, how the control is transferred from first line to the 10th line. So that is handled by the control flow. There are three important control flow statements to alter the control flow depending on the condition or the stage or the state. So one is sequence. Sequence means the statements are executed one by one. Alternative control. There will be a condition, based on that the flow will change. Then iterative. Iterative means based on the condition, a particular set of instruction is repeatedly done. So these three are important concepts which is going to be applied in your programming language. Then functions. Functions algorithm can become very complex. That means if the process is very big, then the process is split into modules or segments. Then each segment is said to be the function. The part of an algorithm is known as function. Algorithm also set of instruction. Function also set of instruction, but the algorithm is splitted into some segments. So each segment can be called as function. A function is like a sub-algorithm. It takes an input and produces an output, satisfying a desired input-output relationship. So to write a solution for a problem, that means to write an algorithm, we must know all the four things. That means the program requires which type of data, then how the data are stored, that is the variable name, then how the controls are flow, that means how the statements are executed. Next, functions. If the algorithm is very big, then it must have modules or segments, that is functions. So to write an algorithm, we need all the four building blocks of an algorithm. I hope you will get an idea what is algorithm, why we need an algorithm to solve a problem. That's all for this session, children. Thank you. Have a good day. Revise it, go through the page, learn well. It is very important. 6, 7 and 8, all the 3 chapters look like a dry subject. That means only of theory. This is completely different from all the 5 chapters what you have learned yet. But even though computer science students must learn 6, 7, 8 with the involvement, or else you cannot learn the further chapters for C++, as well as you feel very hard to learn your 12th standard also. So it will be very interesting. If you don't understand means repeat the lines 2 to 3 times, read it. If you have any doubt, ask in your classroom.